Nominal track gauge is set at 1435 mm and is measured 14 mm down from the railhead. Where the rails separate or converge from this datum, gauge will be reported as wide or tight. The trace records the distance between two rails. Above the datum line on the plus side is wide gauge, and below the line on the minus side is tight gauge. Gauge faults must be inspected using dynamic track gauges under load conditions, shuffle, rail rotation, wear patterns, running bands should also be considered. The actionable limits for wide and tight gauge are speed related and are detailed in Tables 2 and 4 of TRK 001 Module 11. The repair timescales range from 28 days to an immediate block the line, depending on the size of the fault in conjunction with the line speed. They are illustrated in Figure C1. In this example, the gauge varies considerably, with wide and tight sections from 1430 mm to 1463 mm. The distance of this wide, tight gauge is 4 sections on the trace. When looking for the cause of wide gauge, there are several things to take into account. Some examples of gauge faults on wood are chair shuffle. The holes for chair screws in the wooden sleepers have become elongated, and the lateral forces of the trains push the rails and chairs outwards. One of the telltale signs for shuffle is a wear pattern forming in the sleeper. The constant lateral movement creates a sandpaper-type effect, which rubs away the sleeper, causing the base plate to slowly start embedding in the sleeper. In addition, at the end of the sleeper gall, some wood shavings may appear. Chair gall. The foot of the rails are forced outwards by trains and wear away the inside of the housing on the base plate and the adjacent rail foot. In excessive cases, the rail can wear through the housing and into the hole for the clips. Broken chair screws. On high-loaded curves, the excessive forces of trains could shear the screws at sleeper level. The danger is that the screws can appear intact, but under load are not holding gauge. On concrete sleepers, rail insulators can get worn or fall out, and the adjacent rail foot can show signs of wear. If this happens on both rails on the same sleeper, then wide gauge can happen. All gauge faults can be more severe if there are side-worn rails present. The TRV uses a laser optical system and cameras to measure gauge and alignment. This equipment is susceptible to outside interference, ranging from sunlight to severe rain and snow. As this is a non-contact measuring system, occasionally the equipment can be confused by gaps in the rail. Instead of measuring 14 mm below the crown on the gauge face, it measures across a gap in the rail, causing a gauge spike. For example, a joint, IRJ, adjustment switch, or a crossing nose. Incidences of a no-fault found defect need to be reported to the section manager for further investigation and recorded on the fault report. On a tight radius curve, it is likely that a check rail has been installed. If over time the low rail on the curve has head wear, the TRV can show a length of tight gauge throughout the curve. The reason for this is likely to be that the check rail is less worn than the low running rail, causing the laser to pick up the check rail rather than the running rail.